So in this video, let's focus on chemical equilibrium. We are still on that what JAMB gradation question. So you need to pay close attention. Questions like this is what you see in your what in your exam. So you need to pay close attention. So before we do that, let me explain briefly for you. How does change in concentration affect the equilibrium position? How does change in volume and pressure affect the equilibrium position? And how does what temperature affect the equilibrium what position? These are stuff we want to dwell in this video here. So this question I see here is under what concentration. So before you answer this question here, let me explain some here. Here we have two. Here we have this reaction here, A and what B. We have what the forward and we have what the backward. Do you get? It's a reversible what reaction. Now look at something here. Chemical equilibrium will only occur in a reversible what reaction. It means that here we have forward reaction, here we have what backward what reaction. Now whenever you see forward reaction, you're talking about what the product. And whenever you talk about backward reaction, you're talking about what the reactant. Do you get? And to look at things here, here is what is the right. Here is what right, here is what left. Do you get? So the reactant is on the left hand side, the product is on the right hand side. Do you get? So an increase in concentration at a point will favor what the opposite what reaction or what move we test or move the reaction to the what opposite side. What do I mean? If I increase my reactants, an increase in reactants will cause the reaction to what move to what to the product side, which now shift to what to the right. An increase in product will cause the reaction to what move to the reactant side, which is what the left. So these are stuff you want to take note on. What about when you decrease the concentration? When you decrease concentration, it will favor what the same side. Do you get? So if you should decrease the concentration of the reactant, the reaction will what move to the reactant side. Do you get? Because you want pull it out. Now, when you decrease what the product, now what will happen here? The reaction will move to the product side. So these are stuff you want to pay close attention. So we don't understand here. Let's answer this question here. What happened to the reaction above when the hydrogen ion concentration is increased? So I talk about increase in what? In hydrogen ion concentration, which is this guy here. So if I should increase what my hydrogen ion concentration here, what will happen here? It's going to what? Move to the opposite side. Do that. Now, because I increase my products, it's going to what? Move to the left hand side, which will favor what? The reactant side to what? Move backward. Do you understand? So here we have the reaction will not proceed, which is not true. Do you get? Then here we have the equilibrium position will shift to the right hand side, which is not true. Do you get? Because you increase what the right hand side, it has to move to the left hand side. So the equilibrium position will shift to the left. Do you get? So C is the what? Is the reaction. They say that more of the product will form. No. So if you say that C is the what? Is the correct option. Do you get? Because when you increase the product side, the reaction will what? Move to the reactant side. And the reactant side is what is left. Do you understand? So that is it for this question. Let's look at another question. So let's look at this question and say that in the reaction, E plus F give you what? G plus H is a reversible what? Reaction, right? So the backward reaction is favored if the concentration of, now here we have the what? The following option here. So let's check the one that is correct. Pay close attention here. Now, how we change in this reaction favor what? Backward reaction. You need to think here. There are only two ways in which can what? Favor backward reaction. Now look at something here. Backward reaction means what? The reactants. So what will happen, or what will you do for this reaction to favor what? Backward what reaction? And there are only two ways. For example, here we have A, give you what? B. Give you what? B. Now, how will this one favor backward reaction? There are only two ways here. Is that what? You decrease the concentration of the reactants. Right there. Decreasing what? Concentration of the reactant. Now, when you decrease the concentration of the reactant, it will shift backward. Do you get that? Or you increase what? The concentration of the product. So there are only two ways in which what? It can favor what? Backward what? Reaction. What did I say again? Is that what? You decrease the concentration of the reactants. Remember here we have the reactants. And here you have what? Product. Right? Now, here is what is the word backward. Backward. Which was left. It's okay. And here we have what? Forward. Forward, which is what? Right. You know what? Pay close attention to it on here. So, how will the reaction favor what? Backward what? Reaction. Now, either what? You decrease the concentration of what? Of the reactant, or you increase the concentration of the what? Products. Do you understand? So let's consider E is reduced. E is what? Reduced. E is what? Is a reactant. Do you get? So like what I say, is that what you reduce what the reactant side, and E is one of the reactants here. So E is what is reduced, which is okay. Now this one is correct. Is one of the correct option. G is reduced. Then if you should reduce G, if you reduce G, that is you reduce what the product side. It favor what the forward what reaction. So it's not correct. It's not what correct. F is increase. Look at F here. Remember, F is one of the what is one of the reactants. If you should increase the sorry, F is one of the F is one of the reactants, right? If you should increase the reactant side, it will what favor what forward what reaction, which is what wrong. E is what increase. E is increase. E, if you should increase E, it would go forward. Do you get? So this is also what wrong. So the correct option is what E. You understand? So if you're following class, please just say you're following. If you understand, you just say you understood at the comment section. Let's move to what change in what temperature. Let's look at what change in temperature. Okay, now let's look at what change in what temperature. Now this is a regular JAMB question, so you have to pay attention here. Now here we have this reaction here. Here we have delta H is equal to negative minus 13 kilojoules at 298 Kelvin in the reaction above. An increase in temperature would. So how would an increase in temperature affect this equilibrium system? So I want you to pay close attention. Imagine here we have A and here we have what B, and my delta H is what is negative. Now let's say it's negative. Do you get? So we are talking about temperature here. What am I going to do here? My main focus here is going to be what on the what delta H. Now remember, a reaction can either be exothermic or what endothermic. Do you understand? So if a reaction is exothermic, I'm talking about what minus. But if a reaction is endothermic, is what is positive. Do you get? So now there are two things you need to put in mind. A reaction can either be exothermic or what endothermic. If, for example, here we have delta H is what is negative. Do you get? Delta H is what is negative. Now, when I see delta H is negative, is what is less than what zero. Is less than what zero. And if I want to express in terms of what equilibrium, or I want to what solve in whatever equilibrium. Now, because it's negative, it will be treated as what as a product. Now, remember in exothermic reaction, it is what is giving out. It is what is giving out. So whenever I'm talking about exothermic what reaction, which is what negative, I will treat temperature as a product. Why? Because it is what is giving out. So it's going to be delta what? It's going to be what? A the reaction A plus what T plus what T. Now the reason why T is on the product here is because it is what is negative. So it will be treated as a product. Now, but if I ask something like this, now this is called what endothermic what reaction. It is absorbed. It is what is absorbed. Yeah, it will be treated as a what? It will be treated as what? As a reactant. So it's going to be A plus T. Here we have this one here. So you need to understand these two things here. Now, when if I'm talking about temperature, my concentration is going to be what the sign. So a negative sign means that it will be on what product side. A positive sign means that it will be on what on the reactant side. So this is what you really want to put in mind. So here we have negative here. It means that I'm talking about this other one here. Do you get? So I'm going to wipe this for arts. So yeah, now the reason why temperature is on the if you increase temperature, an increase in temperature will favor what backward what reaction. Do you get? So an increase in what temperature will what favor backward what reaction. But a decrease in temperature will what favor what forward what reaction. This is what you really want to put in your mind when solving question when it comes to what or when ask or change your what temperature. So now look at this guy here. Delta H is what is negative 13 kilojoules, right? So in this reaction above, an increase in temperature will do what? Do that. So if I should write this reaction again, here I have H3PO4 aqueous plus what? H2O. Here we have H2PO4. Here we have aqueous plus H3O plus. Now, because it is what is negative, I want to put plus T here. Do that. It is treated as a what? It is treated as a product because it is what is given us. So this will not define everything we are going to answer here. So and remember, an increase in temperature will what favor what the backward what reaction. Do you get? An increase in temperature will favor what backward reaction, but a decrease in temperature will favor what forward reaction. So the question say that in the reaction above, an increase in temperature with what dash with what would a favor forward reaction. Look at something here. If she increases temperature, will it favor the forward reaction? No. So it means that this one is what is wrong. Favor what the reverse reaction. Favor what the reverse what reaction. Favor what the reverse reaction, which is what the opposite reaction. Remember here we have forward, and here we have what a reverse what reaction. So the answer is what is B. The answer is what is B. They have no effect on the reaction. No, it's not. Then slow down the reverse reaction. No. Do you get? So an increase in temperature here will what favor what the reverse reaction, which is what backward what reaction. Hope you understand. Look at what this question under what change the what temperature. Now, if an equilibrium reaction has delta H is greater than what zero. Now, whenever delta H is greater than zero, I'm talking about what a positive. Do you get? So the reaction is going to be what endothermic, endothermic. So that is it is what is absorbed. So imagine you have A going to what B. It's okay. A going to B. They say what delta H is what greater than what zero. They're going to be what positive. Do you get? So whenever what delta H is positive is what endothermic. So it will be treated as what as a reactant. Do you understand? So it's going to be A plus T giving you what B. Now let me tell you the truth. This is one of the most confusing concepts here. This is where actually what make mistake. So now the only way you understand is when you understand when it is what is positive. Now when it is what is treated as a reactant and when it is what treated as a product. Yeah, because delta H is what is greater than zero, it will be treated as what as positive. As it will be treated as what as a reactant. Do you get? So they say that if an equilibrium reaction has delta H greater than what zero, which is what positive, which is what the reactant here. Now the reaction will proceed favorably in the forward direction at. So instead that, how will this one what forward what direction? Do you get? So are you going to decrease temperature or you're going to what? Reduce temperature. That is what they're asking. So because yeah, temperature is treated as well as a reactant. And increase the temperature will favor what? Forward what reaction. Do you get that? And increase what temperature will favor what? Forward what reaction. So the only way this reaction can favor forward reaction is when you increase what temperature. That is high temperature. So let's look at our follow option. Low temperature, no. High temperature, yes. Attaining temperature, no. Minimal temperature, no. Going to be what? At high what? Temperature. So an increase in temperature, yeah, will feel what? Forward what? Reaction. Hope you understand. Let's look at change in what? Pressure.